Hi, I am Yasar Arafath. I am here with another maths video for class 10 CBSE students. I welcome all of you to this video. Trigonometry. So in the last lesson, we have started chapter number 8, trigonometry. In trigonometry, we discuss the ratios between the sides of a right triangle with respect to an angle of that right triangle, an acute angle. So we have discussed the 3 of those ratios. There are 3 more ratios. Total, there are 6 ratios. Okay, so today we'll discuss the next 3 trigonometric ratios and we will do some problems. Okay, so before that, before going to the new ratios, just to discuss, just to revise what we studied in the last lesson, I draw a right triangle here. Okay, suppose the name is ABC, right triangle at B, and which is the side opposite to angle A? BC. Yes, BC, right? Okay, opposite side, and which is adjacent to angle A? AB. Okay, adjacent. So can you please say what is sin A here? Sin A here.
BC by A.
BC by AC. Then what is cos A?
AB by AC. AB by AC.
AB by AC. What is tan A?
CB by AB.
CB by or BC by,
CB
right?
by AB.
BC by AB. Okay, correct. Very good. Okay, so I hope it is clear. So sine of an angle is the opposite side of that angle divided by hypotenuse. So here opposite side is BC, hypotenuse is AC. So BC by AC. Then cos A is equal to the adjacent side of that angle divided by hypotenuse. So AB by AC. And third one, tan A, that is opposite side by adjacent side. So BC by AB. So now we will define the next 3 trigonometric ratio. Actually, those 3 are just reverse or just reciprocals of these 3 ratios. That is reciprocal of sin A, reciprocal of cos A, and reciprocal of tan A. Before coming to that, what do you mean by reciprocal? What is the reciprocal of 5? What's the reciprocal of 5?
1 by 5. 1 by 5.
What is the reciprocal of 3 by 5?
5 by 3.
5 by 3.
5 by 3.
5 by 3.
Yes. So it is also called the multiplicative inverse. Multiplicative inverse. If you multiply a number and its reciprocal, or it's in other terms we can call it as multiplicative inverse. If you multiply a number and its multiplicative inverse, you will get the multiplicative identity. Multiplicative identity is 1. Similarly here 3 by 5 and its reciprocal. If you multiply 3's you can cancel and 5's you can cancel and you will get 1. Okay, so that's the idea. So here the next 3 trigonometric ratios are just reciprocals of these 3. Okay, so here first one, okay, cosecant of A. Cosecant A, I simply write cosecant A, cosecant of angle A. The next trigonometric ratio is cosecant of angle A. I simply write cosecant A, that is defined as reciprocal of sin A. The reciprocal of 5 we wrote 1 by 5. So reciprocal of sin A I write 1 by sin A. 1 by sin A. And we know 1 by sin A, the reciprocal of sin A. Sin A is BC by AC. So what would be its reciprocal?
AC by BC.
AC by BC. AC by BC. So cosecant of an acute angle in a right triangle is 1 by sin A, or the reciprocal of sin A. So you just turn the numerator and denominator of sin A. So you will get AC by BC. In other terms, you can say the hypotenuse divided by opposite side. Hypotenuse divided by opposite side. So this is called the cosecant of angle A. And in short, we can call it as cosec. Cosec A. Cosec A is equal to AC by BC here. Okay, now we move to next one, the reciprocal of cos A, that is secant. Secant of angle A. In short, I write secant A. Secant A is equal to 1 by cos A. 1 by cos A, the reciprocal of cos A. So we know cos A is AB by AC. So what will be its reciprocal?
AC by
AB.
AC by AB. AC by AB. So here AC is the hypotenuse, right? So hypotenuse by
side adjacent.
Side adjacent. Okay. So in any right triangle, secant of A is defined as hypotenuse divided by adjacent. That is the just reciprocal of cos of that angle. Okay. The next one more is the cotangent. Cotangent. Cotangent of angle A.
1 by tan.
Yes, 1 by tan. 1 by tan A. Okay, so here tan A is BC by AB. So what will be cotangent of A, the reciprocal of tan A?
AB by BC.
AB by BC.
AB by BC. So how we can write this in relation to the side side?
Adjacent side by
Adjacent side by, right? Adjacent side by opposite side. Okay. So we got three more trigonometric ratios: cosecant of angle A, secant of angle A, and cotangent of angle A. Okay, here in secant of A we can write in short sec. Sec A. Sec A is equal to AC by AB here. And cotangent. Cotangent we usually take only the first three letters. Cot. Cot A is equal to, we can write AB by BC. So these are the next three trigonometric ratios. They are just reciprocals of those three ratios we discussed in the last lesson. Okay, so sine, cos, tan, and cosecant, secant, and cotangent. Cosecant, secant, and cotangent, in short we can say cosec, sec, and cot. Okay, so cosecant of angle A is just a reciprocal of sine A, and secant A is just a reciprocal of cos A, and cotangent is just a reciprocal of tan A. So there's a chance for confuse. So cos start with the C. So sometimes you may take a cosec as the reciprocal of cos. So that's wrong. First letter, don't compare with the first letter. So here cosec A is the inverse of sine A, and sec start with the letter S, but it is the reciprocal of cos A. Okay, and cot A is the reciprocal of tan A. I hope it is clear. So if I give some other picture, can you find these 6 trigonometric ratios? Okay, I draw a triangle here. Okay, this is a right triangle. Suppose name is PQR. So I think the first 3 no need right now. The ratios we discussed it today. So first one, cosec R. Cosec of angle R. What will come?
PR by PQ.
PR by PQ, right? PR by PQ is correct. Okay, cosec R is the just a reciprocal of sine R. We know sine R is opposite side by hypotenuse. So opposite side of angle R is PQ by hypotenuse. Hypotenuse is PR. So we want to take the reciprocal. So hypotenuse in the numerator and the opposite side in the denominator. So PR by PQ will come. Okay. The next one is secant. Okay, we can write it
PR by QR.
PR by QR, correct. PR by QR. Here we know cos R is adjacent side by hypotenuse, that is QR by PR. So we want to turn it, numerator and denominator, to get the reciprocal. So sec R will be PR by QR, that is hypotenuse divided by adjacent side of angle R. And third one is
QR by PQ.
Yes.
QR by PQ.
Cot
QR by PQ.
is QR by PQ. Okay. So here we know tan is opposite side by adjacent. So here when we take a cot, we want to take the reciprocal. That is the adjacent side comes in the numerator and the opposite side comes in the denominator. So QR by PQ. Okay. 3 more. So I clear this opposite. Okay, it's cosec P and sec P. Okay, just think in your mind. Cosec P, sec P, and cot P. How will come? Okay, I think you got it. Okay, so now you can tell what is cosec P.
PR by QR.
PR by QR.
QR. PR by QR.
PR by QR is correct. What is sec P?
PR by PQ.
PR by PQ.
PR
By
by
PQ.
PQ, correct. And what is cot P?
PQ.
PQ by RQ.
PQ by RQ or QR. Okay. So now it is clear. So now we have discussed the 3 new trigonometric ratios. They are just reciprocals. Okay. And here something, some notes before we move to the example questions. In some terms, we may have to take the squares of these ratios in some problems. So suppose we want to write a sine a the square, sine a the square. So for simplicity, we usually take it as sine square a. Sine square a, that simply mean sine a the all square. For simplicity, we do not like this. Okay. Similarly, cos a or cos any angle here, cos 45 square or something. So we can simply write cos square a or cos square 45. Okay. Similarly for tan. Okay. But at the same time, one thing we cannot do. Suppose sine a, the inverse. We know 1 by 5. We know 1 by 5 is 5 raised to minus 1. The inverse. Inverse of 5. Inverse of 5 is 5 raised to minus 1. We can write like this. So inverse of sine a, sine a inverse, it doesn't mean sine inverse a. The sine inverse a is some special operation we'll discuss in the higher classes, not in 10th standard. Okay. So sine inverse, actually sine a all inverse is actually cosec a, right? Sine a all inverse is cosec a, but this special notation is different. This is some other operation you will study in the higher classes. Okay, so these two we can use. Sine a all square, in short we can write sine square a, and cos a all square, in short we can write cos square a. I think this function actually it doesn't come in our syllabus. Okay, that's okay, that's fine. Okay, and one more note. So Aryabhatta was the first mathematician who used this idea of ratios of right triangles, and he called it as ardhajya for sine. And later, when the books were translated to Arabic and other languages, finally the word changed to sine, S-I-N. And other ratios also, he had some other name like cotija or something like that. Okay.